Welcome to 7.3's Math Moment. Today students learned about ratios, fractions, and fraction notation. Alright, most of their work was done by analyzing a table and really looking at how those numbers worked with each other in order to show different ratios and fraction notation. So the first thing that we're going to focus on is the information that we have. The only section of the table that we have both numbers for would be 8 and 6. So that's where we're going to start our thinking. So just to let you know what we're talking about with the table, this is cups of cereal, and this is awesome squares to fruity cubes. So we're talking about two different types of cereal here, and our measurement is cups. So again, we have 8 and 6. When I think about the numbers 8 and 6, I want to think first about what they have in common. Okay? When I think about what 8 and 6, what factors they have in common, 2 comes to mind, because when I count by 2s, I can get to 6, and when I count by 2s, I can also get to 8. So that information is going to help me make my basic ratio, because a basic ratio is the smallest whole number that you can make with those two ratio numbers. So if they didn't have anything in common, that might stay their basic ratio. But because they have 2's in common, I can make these numbers smaller. So when I think about the number they have in common, 2, 8 divided by 2 gives me 4, and 6 divided by 2 gives me 3. So I can see right away that my basic ratio, when I'm working with these cups of cereal, awesome squares and fruity cubes, would be 4 and 3. So the next step of this table, and I'm going to erase these circles just so we can keep everything organized. So the next part is then filling out the rest of the table based off of this basic ratio. I can move this direction with the table and always be thinking of division. So 8 divided by what gives me 1? Well, 8 divided by 8 gives me 1. The same thing that I do up here should also work with these equivalent with this table down below. So 6 divided by 8 would be the number I'm looking for here. Well, 6 divided by 8 would be 6/8. And I could also think about reducing 6/8, which we use the cake method sometimes in 6th grade, where I pull out a factor they have in common, which we already discussed was 2, and I would get the equivalent fraction 3/4. So your student could work the whole time with this 6/8, or they could choose to simplify it and work it as 3/4. So the next step is going to be looking at the next two numbers that we have and figuring out how they relate to one another in the table. So I look and I have a 6 and a 2, right? So I can think about how can I get from 6 to 2? And I can move either way in the table. I can either move and use division or use multiplication. The only stipulation is however I decide to work, like here I decided to use divide, I have to do that same thing to the top portion of the table. So here, if I decide to go this way with division, I could say 6 divided by what gives me 2? Well, I know 6 divided by 3 gives me 2. All right, and then I would just have to move this same direction with the same operation in order to solve for this next spot. So 8 divided by 3 would be 8/3. If your student would like to simplify and show 8 divided by 3 as a mixed number, they could. 3 goes into 8 2 times to get 6 with a remainder of 2 over 3, so that would be the same as 2 and 2/3. So either way, it's just kind of nice to leave it in this format just so they can see that 8 divided by 3 is right there. That's their same math that they did. So then again, I could start working from any spot in the table where I see an easy connection. I could start working that way to fill in my next blank. So I might see that I don't know what 2 times what would give me 15, or 6 times what would give me 15, or 3/4 times what, but I do see that there's something easy with this 3. 3 times something gives me 15, and I know it's 3 times 5. I can do that as long as I also do that same thing here to fill in the blank that's on the top. So if I did 3 times 5 to get 15 here, I would have to do 4 times 5 to get my answer for this space. And 4 times 5 is 20. So again, I know that this looks like a lot of different loops and that sort of thing. We've got multiplication and we've got division, but what you should encourage your student to do is first start with what information they have in the table that matches. So what do they have in both the top and bottom part of the table? Then they need to start looking for things that they can do in order to make easy connections and do some easy mental math. And as long as they continue to do that to the same number and the same direction, the same operation, they should be able to make some connections with that table. So then, now that we've got our table completely filled out, we have to answer some questions. And this question just says, what is the basic ratio of awesome squares over fruity cubes? Well, I have that information right here. Awesome squares over fruity cubes. This is shaded in because this is our basic ratio. Remember, a basic ratio is the smallest whole numbers that you can get to with your ratios. So again, 8 to 6 is the ratio, 1 to 3/4 is another equivalent ratio, but the smallest whole numbers that I can get for both types of cereal would be 4 over 3, which is my basic ratio for these two cereals. So it says, there are blank cups of awesome squares to every cup of fruity cubes. This is just another way for me to show my basic ratio. It's saying the same thing, awesome squares to fruity cubes. So again, it's just the same thing, written in a different way. And this question says, what is the basic ratio of fruity cubes to awesome squares? So I'm just flip-flopping what I have, pretending that the fruity cubes are on the top of the table while the awesome squares are down below. Or I could also look at this ratio here. If I have 1 awesome squares, how many fruity cubes do I have? It would be 3/4. So this again is the same question. There are blank cups of fruity cubes to every 1 awesome square. How many 3/4 would be the answer? Same exact thing, same question, just written in a different way. This is a tricky lesson, so if you have any questions, make sure to see your math teacher.